Okay, 2025 AMC 12A problem number 13. Let C equal 1, 2, 3, 4, 5 all the way up to 13, and let n be the greatest integer such that there exists a subset of C with n elements that does not contain 5 consecutive integers. Suppose n integers are chosen at random from C without replacement. What is the probability that the chosen elements do not include 5 consecutive integers? Okay, so this seems like it's a pretty complex problem, but first let's just try to see what n is. Let's see what the maximum subset of C is. Because n has to be the greatest integer such that there exists a subset of C with n elements. So we're basically just trying to find the subset of C that's maximal in size but doesn't have 5 consecutive integers. So the way I'm going to do this, just write out all the integers from 1 to 13. And so, well, we can have 1, 2, 3, 4, but we can't have 5 because then we'd have 5 in a row. And then we could get 6, 7, 8, 9. That could be 1. And then we could get 11, 12, 13. And we can't have 10 because then we get 6, 7, 8, 9, 10. So these are the sorts of sets we could have. And so what we can see here is, well, there's 4. This one's going to be an odd one out. This one's going to be an odd one out. So this is suggesting that n is equal to 4 plus 4 plus 3, which is 11. But is that the maximum? Can we leave out only 1? And so the problem is, are we allowed to leave out less than or equal to or less than 2 integers? If we leave out less than 2 integers, say we only leave out 1 integer, we have to prove that there has to be some set of 5 consecutive integers. So, this is pretty evident if you just look at it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You only are allowed to kill one number, and no matter what number you kill, there's always going to be some set of 5 integers. Like if you want to kill this one, then, well, there's the set of 5. If you want to kill like this one, there's still a set of 5. If you want to kill this one, there's going to be a set of 5. Like, it's just not possible. So that's why the maximum here is going to be n equals 11. Okay, now let's focus on, is this the only such subset C, or is this the only such subset of C? Is there more subsets of C? Now that we know n is 11, so we can just try this. Say we're not gonna include 1, then we get 2, 3, 4, 5. Then we can't include 6, 7, 8, 9, 10. Can't include 11, 12, 13. And so this one is actually smaller because we disincluded 3 elements and not 2, so we should probably not do that. And the reason is each one of these groups of 4s needs to sort of have these like padding numbers on the left and to the right of them. And since if our group is on an edge, then we don't have to have this padding on either side of it, and so we can forget about those numbers. But since if the group is in the middle, then we're going to need padding on both sides of it, or like this, we need this sort of padding on both sides of it so there's not 5 consecutive integers. So we basically want to make sure that our groups are always going to be at the edges so we can minimize the number of guys we have to leave out. So, this is just going to be a lot of writing down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, but I think this is just a really efficient and intuitive way. So, we consider this, it's a 4, 4, and this one only has 3. So I'm wondering if maybe we could shift some things around and we could have like 4, 3, 4 or something. So this one's going to be 4. This one, we're trying to make it 4. Then these ones are going to have padding. This one is going to be 3. So that's 4, 4, 3. This is 4, 3, 3, or 4, 3, 4. And there's probably some way we could have 3, 4, 4. So I'm going to do it one last time. And I'll tell you why it's the last after I do it. So we can have 3, then padding, then 4, then padding, then 4. And so these are basically our 3 sets. So we'll forget about this one since this one involves leaving out 3 people. And so these are the 3 sets that only leave out 2 integers. And basically, these are the only 3 sets because, well, there's n equals 11. And so we can have 4, 4, 3 as in the first one where we're leaving out the 2 that's in between. We always have to leave out the 2 in between. We could have 4, then leave 1, then 3, then leave 1, then 4. Or we could have 3, leave 1, 4, then leave 1, 4. And with these numbers, there's no other possible way to arrange them. So we know that the maximum number of sets, or the maximum number of consecutive or maximum number of subsets such that there does not contain 5 consecutive integers, well, we first know that n is 11, but we also know that there's only 3 such subsets because of this logic. So we know the numerator is 3. We can find the denominator pretty easily because we're supposed n integers are chosen at random from C. So that's basically just 13 choose 11. How many ways are there to do that? That's just 13 times 12 divided by 2, which gives us 13 times 6. And I'm not actually going to even solve this because this is our denominator here. And that immediately cancels, leaving us 1 over 26 as our final answer. And so 1 over 26 is D.